Problem is continuous Subarray sum of Leetcode problem number 523. This problem, when we try to look at this explanation, it's very self-explanatory, like what we want to find out here. So it says that there is a number k, and you have to find out a continuous sum in this array. It could be sum of the entire array, or it could be sum of let's say two elements, but they should be continuous, or three elements or four elements. But the result which we want is that sum, the property of that sum should be that it should be a multiple of k. So what are multiple of k? Multiple of k equals to 6 are 6, then 12, then 18, and so on and so forth. Okay, so we want to form that sum. Okay, like to form the multiple of 6 here, we can see 2 and 4. That is summing up to 6. Okay, so it says the sub array should be of size 2, at least 2. Okay, so we cannot say that okay, this 6 is there and 6 is a multiple of 6, so we are done. That is not correct. So this would return true because 2 and 4 are summing up to 6. Now looking at this example, so here they have interchanged the position of 6 and 4. So how does it form a subarray? We see 2, 6 and 4. This sums to 12. Okay, so this lies in the table of 6. So that is a multiple of 6. Okay, so this should also return true. Okay, so how to find it out? Okay, so one brute force approach could be to, I'll explain it through this. The brute force approach could be that given this array, we keep two loops. Okay, one loop will go through I equals 0 to n, and then we will have j equals I plus 1 to n. Okay, or rather, yeah, that is true. So I equals to 0 to n, j equals to I plus 1 to n. And what you will do, so this loop will essentially say that okay, I will remain a constant here and j will move from here to here. Okay. Then I will become 1 and j will move from here to here. And we'll calculate all the sums, and then we'll try to find out whether that is a multiple of 6 or not. Okay. So it essentially says that okay, first we'll find the sum of this. If it is not a multiple of 6, then we try to find out a sum of this, then we try to find out a sum of this, and then this, and similarly here we are going to find the sum is 6, that is a multiple of 6, then we are going to stop. Okay, so the brute force approach says my time complexity is going to be n square. Okay, so this is going to be the time complexity because we are taking two loops. Okay, and the space complexity is constant, big O of 1. Okay, now how to optimize it, because surely this is not going to be accepted, this is not going to be an accepted solution in your interview. So how to find an optimized approach? Okay, so first of all, how do you find out whether a sum is a multiple of k or not? You can easily use a modulo operator. So if that modulo operator returns, so let's say if you do 12 mod 6, then it will return you 0 because this modulo operator returns you the remainder. So if the remainder is 0, it means that number is a multiple of k. Now we say that we want to calculate a sum of I to j such that sum mod k is equals to 0. So we need to find out such I and j for which this property holds true. Okay, so how to find this out? Okay, so we cannot have two loops that would result in n square time complexity. So what can we do here? If you look at this, we can say that okay, if my I remains constant, let's say if my I remains here, and I move or I calculate the sum from from here till here. Okay, this sum, then I calculate this sum, so that is easier. So what I'm trying to say here is if I want to calculate sum of 0 to 1, then I want to calculate 0 to 2 or 0 to 3, or 0 to 5, 0 to 4, 0 to 5, something like this, that is simple. We can do it in a single pass. We can just try to accumulate it and try to formulate it. Now, what benefit this would solve is, let's say you have a sum of 0 to 1 and 0 to 3. So, what it means, you have this sum, okay? Let me just highlight it. You have this sum, and then you have this sum 0 to 1 and 0 to 3. Okay, if you subtract these sums, then you can easily find out this sum, right? If we subtract this from this, then this is gone and we are left with only this. Okay, so if we say that I have a sum from, let's say, 0 to I, okay, and I have a sum of 0 to j, then I can easily find out the sum from I to j by subtracting these sums, right? This is one property which we just saw. But do we really need to maintain these sums? Okay, if we want to maintain these sums, then it's at the last, what we want to do, we want to calculate the modulo, and if that modulo is 0, modulo k is 0, then we have found that ing. Okay, so what we want to do here is, let's say my sum of I, I'll represent 0 to I as I. My sum of I is A into K plus B. Why I'm representing it in this format? Because there will be some component out of this whole sum, which will be which will be multiple of K. It This here A could be 0. It means there is no such component. Let's say if K is 6 and the sum itself is 1, so it will be 0 into 6 plus 1. Okay, so we can represent it in this format very easily, because this in itself is if let's say it is 6 itself, so here B will be 0. Okay, so we can easily represent it in this format. Now, similarly, we say sum of j is, let's say, C into K plus D. Now we have two sums here, right? We are trying to create the or calculate the difference of these sums. Okay, so what I say, if I have these, I represent sum of j uh, minus sum of I. What will it be? We do a simple math. We say C minus A. I take K constant. Okay, and then I say minus, sorry, plus D minus B. Okay, so I just subtracted these sums. Now, if you look at this equation, it is telling you a very important property. It says that, hey, C minus A is already a multiple of K. So I'm not bothered about these. I am only bothered about D and B. Now, how will this sum of J and sum of I, their difference, how will it be a multiple of K? So it will be a multiple of K if and only if this amounts to 0. Okay, so this sum, this implies that this sum will be a multiple of K only if D minus B is equals to 0, which means D should be equals to B. Now, what is this D and B? So, when we try to create its modulo, right, if I say sum of I modulo K, then this will be gone and we will do B modulo K. Okay, so we will be left with the remainder. So, this is essentially the remainder. Okay, so here both B and D will be greater than equal to 0, okay, and less than equals to K, because we are, or it will be actually less than K. So what we are doing, we are calculating the modulo, and its modulo, anything which is greater than K, it will reduce between this number. Okay, so we say if we just try to try to accumulate the remainders. Okay, so how will I reduce this problem? I'll say that I am trying to calculate the sum. Okay, I do its modulo with k. Okay, and then I place this remainder in, let's say, a map. Okay, I place that remainder in a map, and then I do the same all over the array. Okay, in a single pass, and I try to check whether I have found it remainder already. It means that I have D, now I'm searching for B. So if I find the same remainder again, it means my problem is solved, because I have found that numbers which will reduce to k, or which are a multiple of k. You got my solution? So what I'm trying to see here is, I'll keep a map. Okay, what this map will keep is, why I'm keeping a map and not a set, I'll tell you here. So I say I'll keep a map of integer and integer. Okay, and here I say that the key would be, the key is going to be what? It is going to be the remainder, because we want to search by remainder. That is this one, right? This D and B. And the value is going to be the position. Now, why I want the position? The position, let's say I am calculating this sum of j and sum of I, so I want to store this I and j. Why I want to store this? To satisfy the property, this one, that it should be of size at least 2. So whenever I find the same remainder, uh, or the remainder already existing in the map, I will subtract the positions, and I'll check that if it is greater than 1, then only I'll consider that answer. Otherwise, that is not a valid answer. Okay, so that is my algorithm. Okay, I'll just keep a map, and I'll keep checking into that map. If I already have that remainder, then check for the positions. If that positions difference is greater than 1, then I have found the answer. Otherwise, it's not the answer. Okay, it might be a this situation where I have a single 6. Okay, so I'll write this solution, and then I'll do a dry run through both of these examples. Okay, so what I'll do here is, first of all, I'll check, or let's say I keep a map here, integer, integer. Okay, and what I'll do is, I'll go through each of these numbers. I'm doing a pass over here. Now, here what I'll do is, I want to calculate the sum. So how will I calculate the sum? I'll say I take a value, let's say remainder, that is equals to 0, and here I'll say remainder plus equals to nums of I. Okay, and then I'll check. So I have to check this special condition. If k is 0, then we should not do a modulo of it. Okay, so if k is not equals to 0, then what I'll do, I'll say remainder mod equals to k. Okay, and then I'll check if map dot contains key, this remainder, then what I have to do, I got this b, and now I found the d here, right? This situation I want to resolve. So what I want to do here, I want to check the position difference, right? So I'll say if map dot get remainder minus, or rather I would say, because I would be greater, right? We are doing a single pass. So I say I minus map dot get remainder is greater than 1, then I will return true because I have found the answer. Okay. Otherwise, so this says if it is already there in the map. Otherwise, what I'll do, I'll say map dot put. I'll put the remainder along with I. Okay, so I'm just populating the map along with the position of that remainder. Okay, where I have found that remainder. I'll keep doing this. At the end, I'll return false if I have not found a suitable match. Okay, we also want to initialize this map with 0, comma minus 1. This is to handle the case of if the array is 0, comma 0 and k is 0. Okay, so in this case, our position is minus 1 and this would already be true. So this is to handle the case of k equals to 0. So submit it. This is accepted. So the time and space complexity for this would be, the time complexity would be big O of n because we are doing the single pass, and space complexity would be big O of k. Reason being, so this is single pass, right? 0 to n. So this is going to be the time complexity, big O of n, and the number of entries which will be there in the map would be k because we are storing the remainder, and remainder will always range from 0 to k, right? Because we are doing a modulo, and the values in that map would only range from 0 to k, none other than that. So that is why the space complexity is big O of k. These examples, it will also explain you better the process which I had explained you here. Okay, so first of all, let's take this example. We have 23, 2, 4, 6, and 7. Okay, so initially my map would contain 0 will contain minus 1. 0 is the key, that is if my k or the modulo is, the remainder is 0 and the position is minus 1. Why are we taking this? It will be clearer to you. I'll quote some examples here. Okay, so remainder I'll be tracking here. So initially my remainder is 0. Now I go through this loop. So I'm going from here till here, that is 23 till 7, and I add the number to the remainder. So number is 23. Okay, so my remainder becomes 23. Now k is 6, so k is not equals to 0. So remainder mod equals to k, that is 23 mod 6 will give you 5. Okay, so this 5, we got the remainder is 5. Now we check here if map contains key 5. Map doesn't have 5, so we'll put it here. Okay, we'll put 5 here with index I, that is 0. We got 5 at 0th index. Okay, now we move here. So here we got 5, right? Now at 2, what we will do, we will again add, now this remainder is now 5. Okay, we add this number 2 to the remainder. So 5 plus 2, this becomes 7, and 7 mod 6 will give you 1. Okay, so again we check if map dot contains key 1. No, it doesn't contain, so we'll put it here. So we'll say 1, and the position at which we got it is 1. Okay, so here only we got 1, so the position is 1, so we'll put 1 here. Okay, now we proceed further. Now our remainder is 1, we add the next number, so that is 4 at index 2. Okay, so we add 4 here, and then we do a modulo 6. So 5 modulo 6 will give you 5. Okay, because 5 is lesser than 6. So now we check if map dot contains key 5. Yes, it already contains. Now what we have to do? We have to see the current index I, that is 2. Okay, this is the remainder was 5 and the index is 2. So we say 2 minus map dot get 5, that is 0. So 2 minus 0 will give you 2, that is greater than 1. So we'll return true. So here we stop our loop. Now let's try to understand how in the this functioning, how it happened, how it was proved true. So we say 5 remainder was at position 0. So here we had got 5 remainder. Okay, and here also we got 5 remainder. Now what I'm doing this index, that is 2 minus this index. So essentially I am doing, if I compare it here, I say sum of, so this sum j means 0 to j, right? So I'll say sum of 0 to 2 minus sum of 0 to 0. This is what it means. This is what we are doing. We already had this remainder in the map, and again we got the same remainder at index 2. So what we are trying to do, till here we have the remainder sum, that is 5, and place where we had already got this remainder was index 0. So we remove this thing from the uh, from the consideration, or we subtract this sum. Okay, and if you see, this proves it that 2 plus 4 is 6, and this is coming out to be true. That's the multiple of 6. So this is how we are solving. When the remainders come true, then we, so this is a subtraction of sum, right? We are subtracting those sums. So we have this complete sum, and we subtract this 23 from this complete sum, and we get the exactly same remainder. Okay, so this proves it. Now let's go through this example as well. So let's come to this example. So we have 23, 2, 6, 4, and 7. So we will start with this. So initially 23 would be there. Okay, so initially my remainder contains 0 and minus 1. Initially my remainder was 0. When we got through this loop, so remainder we add 23. So it becomes 23, and k is not equals to 0. So remainder mod equals to k will give me 5. And map does not contain the key 5, so I'll put it here. I'll say 5, and my position is 0. Now I add a, so my remainder here is 5. Okay, now I add a 2 here. Okay, so 5 plus 2 will give you 7. Okay, and mod 6 will give you 1. So remainder here comes out to be 1. 1 is not here, I'll add it. 1 at position 1. Now I add 6 here. Okay, so remainder plus num, that is 6. So 1 plus 6 will give you 7. 7 mod 6. That will again give me 1. Okay, now I check if map already contains that remainder 1. Okay, map already contains it, and this remainder I got at position 2. Okay, the remainder is 1 here. So what we do, we will say I minus map dot get 1. So map dot get 1 was 1, and this is 2. So 2 minus 1 is 1. This won't return true. We'll still continue to explore further. Now this is fine, right? This is how we are handling. So why the remainder was same? So we will say this sum minus this sum gives us 6. But the length of this array is 1. So according to the question, we don't want to consider such scenarios. We want the length of the subarray to be at least 2. So we will reject this through this condition. Okay. Now we proceed further. We say 1. So remainder is 1. 1 plus next digit is 4. So we say 1 plus 4. That becomes 5. Okay. If we do a modulo of 6, that will also give me 5. Now I check if map contains 5. It already contains. Now I got my 5 here. Okay. So this is at index 3, and I had got last 5 at index 0. So I say 3 minus 0. That is 3. So that is greater than 1. So I'll return true. Now how does it signify here? We say this thing, that is 23, okay, and this whole sum. Okay, so I'll highlight it here. So this whole sum minus this 23 leaves you with this value. Okay, So this says 6 plus 4 is 10 plus 2 is 12. So this will give you the answer. Now, I'll also give you an example how this is helping us, 0, comma minus 1. Let's say we take up this example and I'll modify it further. I say instead of 2, let's say I have 1 here. Okay, now let's run through this example. So initially, this would remain same, right? We have 23, so we add to the remainder 23 and then when we do a mod of 6, so we get 5. So this is my situation. My remainder is 5 at position 0. Okay, so here the remainder is 5. Now I proceed further. I say, okay, to 5 I add the 1 again. Okay, so it becomes 6 and 6 modulo 6 will give me 0. Okay, now here I'm getting the remainder as 0. Now I come to this condition. I say if map dot contains key 0, then I try to check this position thing. Okay, so my current I is 1. 1 minus my map dot get remainder is minus 1. Okay, so if I do 1 minus 1, this becomes 1 plus 1, which is equals to 2. So this is greater than 1, so this would return true. Now how it holds in the example. So if you see 23 plus 1 gives me 24 and 6 fours are 24. So this is a multiple of 6. So how placing 0 comma minus 1 helped us? Because at position minus 1, that is out of bounds of this array, we have the remainder 0. Till now we do not have any number. So we are just keeping it as a base case to achieve these, to achieve this result. Okay. Hope it is clear to you now. And if you like this video, please subscribe to my channel. Thank you so much. Bye bye.